We're going to kick off. It's good to see. I thought, last session I might slow things down and let people enter, but it's cool to see that we have pretty much a full room. I feel like my horde has come to me. Sorry, terrible. For those who don't know me, my name is Jack Condon. I live in Melbourne, Australia. It's very far for me to come here, but I'm very excited to be here to talk about Horde because I think it is pretty amazing to leverage and sort of help a lot of teams. So it's something I'm quite passionate about talking about. Today we're talking about an introduction to Horde, a technical primer. So what does that mean? Let's go through it. Once I find my clicker. So I guess I'll start very high level. This is not a high level presentation. I'll get into that in a minute. But I want to start with Bushranger here. Bushranger's asked us all a question. What is the wrong with the way I'm doing things right now? Well, what are the problems that we're talking about today? Perhaps you've not been doing enough testing during development and know what issues you're going to have on your actual target device. Yes, we've all been there. We've all done that. Maybe you're struggling with issues of changes being pushed that are just getting in the way of other people working, right? You're stepping on each other's toes in certain ways. Or maybe your team is spending a lot of cycles just building the engine on their own machine. Or perhaps QA testing is just taking too much time, and that means you're not finding all the issues that you need to find. CI/CD is the solution to this. What is CI/CD? CI/CD stands for continuous integration and continuous delivery or continuous development. Okay? And I'll just give you the really basic outline of that. But the basic concept is as we push new incremental changes, we run a build and test, aka continuous integration. And then the system is able to deploy these builds somewhere, say for QA or review or even release, right? The idea, I suppose, is that we're automating most of the manual parts of our software development pipeline to speed things up and make them easier, right? So what is Horde? Horde is a set of services supporting workflows Epic Game uses to develop Fortnite, Unreal Engine, and other projects. Most of you probably know Horde as Epic's CI/CD service, but whilst that is one of its important things it does, it is also many other things as well, which I want to explore today a little bit. So it's just important to note at this point that Horde's features are actually modular, meaning it doesn't need to be a CI/CD service, okay? But that's primarily about what I'm going to be talking about today. So for the purpose of this talk, yes, it's a CI/CD service, but it's tailored specifically to the way we work with Unreal Engine. So why use Horde? Well, I just kind of mentioned, it is specific to how we typically work. The workspace is set up to how Epic do projects, and it integrates with our existing tools, such as UAT test results, Gauntlet, and UGS. Horde also comes with a lot of stuff ready to go in Unreal Engine. This is a huge advantage if setting up your first CI/CD or even just moving from another one, as you can set up things like Gauntlet and UAT tests, pre-flight tests, metadata and binary storage for UGS much faster and easier than other solutions or previously. It's also worth noting, Horde started as an internal tool. Not just for Fortnite, but also other things like our engine, right? And it's even used for other tools such as Fab. My point here is that it has been battle tested in an environment with a lot of users. Also, Horde is built around Perforce and Build Graph, and this is a positive if you are using those tools. But if you're not, this can be seen as a significant extra challenge, and I'll cover that a little bit more later. This is the agenda, sort of. I have tangents. I tend to tangent, I'm sorry. But look, as I said, my goal is not to cover high-level features about Horde in this presentation. It's my hope at this point that you've seen the amazing team talk about all the new stuff like Zen streaming, and you've seen all these high-level concepts of what the tools can do. That's not my plan here. My goal is to essentially run you through your first implementation by creating a feeling that myself and you have sat down together and I've been like, hey, look at all these cool things. And you're like, wow, that is cool. And my goal is that I'll feel successful if you feel more comfortable within Horde, and you feel like diving into Horde, or if you just get a sense of what it's like to work with. So to get an idea, who here has currently integrated Horde and is happy with what they're doing? Okay. And who is kind of started to implement Horde? It's kind of an experiment. It's on their own personal machine. Is there anyone kind of there? Yeah. Okay, cool. And who hasn't even touched Horde, but they've seen the high-level presentation and like they've got the buzz. They're excited. Everyone else, basically. That makes sense. That's why you're here. Okay, great. Well, I think you're all still in the right room. I'm going to be trying to share some tips and tricks that may have been missed as well. So Bushranger comes up and he says, okay, yeah, but how do you actually do it? Is it easy? I think the easiest way to answer that question is just to do it. So let's dive in. And we'll start by installing Horde. So a quick note before I install this is that Horde can be set up fully on-prem, on the cloud. Likewise, an agent can be on the cloud or it could be on-prem. One thing I quite like about Horde in the way it is my ability to sort of test things locally before sort of a more mature deployment. But the easiest way to deploy Horde is on Windows. Yes, I am a non-dark user. I'm so sorry as you all. I'm just waking you up. It's like 4 p.m., right? But you can download the MSI from our GitHub. We're going to be working with 5.5.4. And it can be found inside the releases itself. I will be covering ways about how to build and deploy via Docker later. But this is just to get us started really quickly. So once it's installed, we can see that it already generates us a web page, and it holds amazing documentation to get started. And you can always be specific about the version because you can find the version's information inside the help. This is more for prosperity for people in the future who exist in the internet. So the first thing a lot of people will want, specifically if you are switching from another CI/CD like Jenkins or TeamCity, is of course build automation. I want to show you first how to set that up and how to configure Horde. So Horde is primarily configured through a group of JSON files. There are a lot of them. You're going to become very good friends with them. So I want to slow things down and kind of define what they're useful for to begin. This is the majority of them and how they relate to each other. Note, do I have a laser pointer? Oh, yes. Note that they've got a one-to-many relationship in some circumstances. But the thing is, this mirrors the way we typically work. We'll have source control for a company that will contain many projects that we're working on, and each one of these projects will have multiple streams for different development and releases, okay? The global file is going to be where things kick off. It handles a lot of how you want your Horde to be configured. It's not the actual origin point, but we'll get there. It's where you define what projects your teams are working with, what plugins you're using in Horde, and how they're configured. Remember I said Horde is modular. Access control lists for users, how you want to set up storage, things like that, many other things. But what we're focused on is we're going to start letting Horde know about our project, in which case Lyra. And to do that, we need to define the project in the build plugin. So here we will specify a path to a new project.json file named Lyra, so we can identify it easily. Now, Horde comes with a bunch of boilerplate done for you. So most likely, at this point, you're just copy and pasting and you're updating files, okay? You'll be making a new Lyra project based on the provided UE project.json. And with that, we have Lyra in our dash. But of course, we could add other projects as well. So what does a project file do? They're really simple. We just list the streams that we're using, right? They also have some nice, fun features. We can customize the UX of how our streams are displayed. They can also define a cute little banner for each project if we want to make things feel more like home, which I think is important. So we define streams, we just create stream files. And once again, you've been provided one, and you can reference it here. One thing I want to note when we're making references is that each reference file is relative to the file we're writing in. And that's going to come up later. Here's how we, configure UX and whatever else. So stream files, these are the most exciting. If you've forgotten everything, that's okay. Stream files are where we're going to do a lot of the work. It's where we define jobs, what's going to be available to the user, and define all the parameters for them to interact with. In fact, the provided examples have a ton of gems in them. And I just want to take a look at a few because I want to show you what you get. So you can see here, we have predefined categories, and we already have a heap of jobs we can look at within this. We've got an incremental build job for producing binaries for UGS. We also have an option to package and test builds, where we can specify platforms. Pardon me. We have an example of a pre-submit test to run tasks on shelved changes and then automatically submit them if no issues are found. As well, we have a way to create standalone builds of Unreal Engine if you're not using UGS. And we have a bunch of utility demos as well. So this one is really useful. It's just all the parameters. And so what I do is I just copy and paste what I want out of this one when I need my little options. But if we go ahead and run a job, we're going to get stuck on waiting for an agent. So an agent is a workstation that is able to run sections of our job distributed by Horde, but defined in build graph. Agents make a direct connection to the Horde server, and it monitors their activity, only assigning them work when they're not performing other jobs based on other specific criteria as well. So in this case, we're looking for a win UEFI type to do the work. So how do we set up an agent? The process is really simple. The software required to run the agent can be found inside Horde, inside the downloads folder. And if we're setting up a Windows agent, we just download the installer from here. Once it's installed, it will automatically open Horde and ask to enroll. Now, this will authorize the agent for Horde, with Horde and allow them to communicate. It's like a handshake. You can also find this in the Horde dashboard if you miss it. And like that, we have our first agent. Here, it will tell you as like a hyperlink if it's busy doing a job. That's really useful because if you can imagine you've got lots of agents, you can get a quick look at what they're doing. You can click, go straight into it. It's very nice. Also really nice for people who have managed build farms, and the most common, I see some smiles. Yes, hard drive space. Why did it crash? Oh no. Yup. And this idea of pools over here, and we'll notice one is called Win UE5. So pools define what kind of work an agent is appropriate for. An example could be, a Mac agent for compiling and testing on Mac, right? Makes sense. These can have rules to auto-apply to our agent based on operating system and hardware. Of course, you can also assign them manually as well. A quick tip, running the Horde agent will actually show you the properties that you can kind of access for these conditions. So now we have an agent, we can run our jobs, and it looks like we found it. We've made some progress. And that's because, once again, we've defined it as a Win UE5. So these can be further allocated inside your global.json. Let's start our job. Let's make sure it all works. Yes, I sat here and I recorded my screen while I built the engine. But I thought it was important to get the full immersive experience. And as you see, we've got it. We feel like a wizard at this point. We've done very little. And we even have artifacts. So, right, this is the beginning of a CI/CD pipeline, right? And we're able to download them. So, a question. Do you ever get frustrated waiting for your projects to compile? Do you ever get sick of constantly testing your builds to see if you've fixed issues? Are you guilty of not testing enough package builds? This is like my infomercial voice that I'm doing. Let's talk about package builds and testing. So we've already had a look at this job that's been provided. And it's time to look at JSON again. But because we know it's a job, we know we can find this information in the streams.json file, specifically the area responsible for packaging build jobs. But this is the key takeaway that I want you to understand about jobs, or even broader, what I want you to understand about Horde. A job is basically a way to call build graph with a specific script and target. A build graph handles the rest of the work for us. So you can find a very powerful build graph script in your engine folder. It's called build and test project.xml. Most of the examples provided will use this in some way. And there is a lot of functionality there for automation. But of course, if you're already using build graph, you can just point to your own. For those who don't know, this is the supplied target inside a build and test project. This is the specific build graph node that we want to get done. And you can see it has a bunch of requirements, and that ultimately defines our whole job. But I really, once again, want to stress this point. Horde is unlike any CI/CD platform as it's designed to work with build graph. That's ultimately what is being executed, okay? But what about all these parameters and that are being displayed to users? Well, these are defined in stream JSON as well under the parameters object. And we can see all the settings of each being defined here and how they relate to the final outcome. The example is this editor window. But each option can have an effect on build graph through how it's going to execute by providing arguments, right? So that's how that all works. A quick tip, if you are making job templates, is you're able to use this template editor to give live updates when you edit the JSON, and then you copy it back into stream.json. It's not quite a WYSIWYG editor, but it is rather nice, I think, to work with. You combine that with the utility example I showed before, and you can get a lot done. So let's run a job and see how it goes. And it looks pretty good. However, we can see that some of our tests didn't trigger. They're looking for a specific agent, a WinUE5 GPU agent. Horde didn't find this agent, so the task was skipped. So, when working with agents on Windows, you need to be aware that you can run them in two separate flavors, as a service or run by the user. A Windows service won't be able to launch standalone builds of the editor or package projects. So you're not going to be able to work on this machine if you want to use it for testing. So let's disable our Horde agent service and run it directly. Thank you. I'm gonna have some water, and we can watch me doing this. So we're gonna run both editor tests and target tests. Editor tests are just a really great way to save time on builds because we can actually catch issues faster before we cook and package if it fails in the editor. That's what's happening here. We're running through all Lyra's tests, which is pretty cool. And finally, we'll do our package, and then the same thing is going to repeat on our package build. Just like that, we have testing, and we're feeling pretty cool. So a common feeling when you're working on a big project is fear of breaking the build and costing your entire team time. I think we have all felt the same way that Bushranger feels right here. Ideally, there are safeguards, but it can still be terrifying. Or it was working on my machine, which you can always just say, well, we'll ship your machine then. But it's not actually the answer. Different development environments can cause different problems across the team, of course. Look, one of the best safeguards, I think, is called a pre-flight check. The idea is that you're able to submit a shelf change and run tests on it before committing it to the stream. This by itself gives a lot of peace of mind, and it's a pretty easy thing to set up with Horde. To set this up, we're going to download something called P4V extensions from the downloads page. You don't need this next tool, but it's a great option for P4V, and it makes the process sexier, at least, I think. To install it, we just run the install command, and it will run a script on P4V. But do note, we need to give it some information in its INI file. We're only going to worry about the Horde server. It does a bunch of other cool stuff. It's just outside of the scope of this talk. But when we do that, we have Horde, pre-flight, and submit in our change list now. So if I click that, it will essentially open Horde with the pre-submit test and shelf change window. Now you can just click start. Optionally, you can turn off automatically submit on success, but typically, that's what we're doing. But actually, any job in Horde can have this shelf change and auto submit option. So you could have ran a package build and test and done the same thing. And then have it auto submit once all the tests pass. And just to be clear, the P4V extension plugin really just opened that web page, right? That's all it was doing here. You could do all of this from the Horde dash. Cool. But do I need to run a job whenever I submit a source control change? And of course, what about nightlies? Of course, we can trigger jobs based on criteria, such as when the new change list is available. This can be done on a per job template level with the schedule settings. And so each of our job templates will be found in our stream.json file. We're going to be looking at the incremental build as an example. These are our specific settings I've added into that job, okay? So we've got essentially a few things. We can turn on and off our schedule. That's kind of useful for debugging, in my opinion. Max active refers to the maximum number of builds that can be active for this job type at once. You've also got max changes, and this refers to the maximum number of changes the schedule can fall behind the head release. This one here means that we actually need a change submitted, and filters are interesting. In this case, we're saying that content filters won't trigger this job, okay? And finally, we have a way to specify when we poll and how fast we poll in the pattern settings. Once that's all working, we can see our schedule in the summary section of our stream workspace. There's also a log, which is very good to see if you got your actual settings correct, right? Very good way of debugging that. There's a lot of settings available too, so you can check that out in the configuration documents. You keep saying UGS in this presentation, and I have no idea what you're talking about. And that's fair. I think we should start talking about it because it's definitely worth talking about. So Unreal Game Sync is a really powerful tool. It's a Perforce frontend that can sync with powerful filtering to save on iteration time and automatically build the engine if it needs to. It's really great for keeping the engine and a project sort of in lockstep as well from a user interface perspective. And it adds a lot of great metadata to specific change lists. It can also handle precompiled binaries and makes the entire experience of dealing with source control just easier. However, a lot of teams have been hesitant to use UGS because it was perceived as difficult to set up. And I'm here to say that that has very much changed. So let's have a look at doing this now with our Horde setup. We're going to go back to our Downloads tab, and we're going to go ahead and download the installer for pre-built Unreal Game Sync. Installing it is easy. We just specify our Horde URL. Then we want to open a project. Project in this context is going to refer to a uproject file in stream. There we go. We're going to select Lyra. And that is the basics. We have UGS working. It's pretty much easier. I see people smiling because they're like, oh no, I did it 2 years ago and it was hard. UGS has the ability to add notes, statuses, and other metadata to builds. And this can be a really good way to check a change list health or a whole host of other things that can happen in development. I was having a conversation where people were experimenting with putting in performance metrics into it. I thought that was interesting. Previously, setting up this metadata server was a bit of a hassle, but now Horde can host this metadata. So if you've set up this metadata, you know that it was a little bit tricky. It wasn't so straightforward. But now all you need to do is you open up Unreal Game Sync INI. You'll probably find this, like, you can put in an engine or a project. I suggest putting in your engine. But from here, you just add your Horde server URL, like this. And after that, you have UGS metadata set up and running. It's kind of never been easier. While I'm talking about UGS, a nice feature that involves Unreal Game Sync is the message window. This is a great way to let people know that, like, you're at feature lock, or just be like, stop pushing bad code. I don't know if that'll work for your studio, but you can at least try. We can do this in the same engine level, but we also can put the Unreal Game Sync file in our projects. And so I think that works to put the message in the stream it's kind of associated with. And so locally you can place this file as an override in your project build directory. Then you specify a stream, a message, even a color, and it also supports hyperlinks. And you can see it's working. You can harass your whole team, which is good. But ultimately, it should make onboarding much easier. I'm an artist, and I don't ever want to open Visual Studios. Oh my gosh, well, you can't please everyone. But I did mention UGS can automatically build after syncing, and that's already going to make this problem specifically easier. Why do I need to compile the engine source code? I'll never change it. That's someone else's job. It's a very rude team I've got here. Compiling the engine takes too long and makes my CPU go brrr. It's my best CPU noise. There are many people on a team who may not want to spend their time compiling the engine, and reading over engine source code might be their idea of a nightmare. Unreal GameSync can download pre-compiled binaries for these people. Previously, this too required setup, a bit of setup. It was probably its own talk, if I'm honest. But now all we need to do is select the Options tab here. Then we sync precompiled binaries, and we're good to go. But you might notice that our change lists are grayed out. And that means there's no precompiled binaries for these changes available. Once again, Horde is the answer to both building them and storing the artifact. All we need to do is run the incremental build job here, and the change will be available. So do you have problems sharing dev kits? What about in remote scenarios where you only have one of each device? Or maybe you don't wish to always have to just pick up your mobile phone and play through the same levels, because I know any kind of device testing, that's what I really hate. A lot of you here are working on cross-platform games, I bet. Put your hand up if you're working on cross-platform. It's like the entire room for the yeah, everyone basically. And it means a lot of you probably have experience with Gauntlet. It is a fantastic tool for handling deployment and testing on devices. The next chunk of this talk will go over Horde's features to make this really easy. And I'm going to be using my very cheap Android. But, you know, when I say devices, I am speaking more broadly about different devices that you might use. So you might have already seen in previous slides that we have a mobile as an optional target when we're making a package build. But when testing and deploying, we still need to tell Horde what device we intend to test on. So Horde has a device dashboard that lets us add devices really easily. It's got some great features for tracking, but for now I just want to point out that we can list our devices by address, either via its address that comes up when it's plugged in the case of Android, you know, or Wi-Fi address in the case you've set up ADB Connect. However, if we run a job, you will see that we're actually unable to deploy the test to this device. And that's because we need to know what agent is actually responsible for pushing the content to the device, right? And you'll see that build graph is looking for a pool known as Win Dev Kit Automation. So how do we add this pool? Well, it's pretty simple. We just add it to our global file by adding it to our compute settings like this. And you can change, for references, you can look in global default JSON, which can be useful. Now we can select the agent that we're dealing with and click edit. And we select our new pool, and it will conform almost immediately. Let's check out the entire process. I've got some dodgy handheld filming here. But the reason I had to show this again was that this is the point, if you've ever done any automation, that you feel like a wizard, right? Especially when it's like a tablet that's not plugged in and it just opens your game and it just starts playing it and you're like, ha ha, yes. And once again, I want to say that we haven't done an awful amount of work together today. So I wanted to expand on this. Testing being that easy, I wanted to highlight a bit more about how we can write simple tests with Blueprint in Unreal and have their outcomes sent from our device back to Horde to look over. One such way is to make a test using a Blueprint functional test, which uses the Blueprint functional test plugin. This will allow us to write test classes and have them work right away without C++. This is cool because it can encourage technical designers and technical artists to help write tests if you've got that kind of culture. But to make one, you just want to make a class of a functional test. This is a really crude one. It's going to record the FPS of the scene. It's important to name this level to start with ftest underscore. This test is going to allow me to specify a sequence to play, as well as a minimum viable FPS and a total capture time. This is very crude, and it's not the way you should handle performance tests, okay? If you want to see a much better way of handling this, go see Matt Osterley's talk on this very subject. This was a ploy to promote that talk. You've been ployed. But I really just wanted to illustrate how these things kind of are all connected. So when you set it up with the right level name, it automatically appears in the session front end. This tool allows us to run the test. That's already pretty cool, in my opinion. But you'll see that it returns with some log about the test, basically highest frame, lowest frame, and the average. Inside Horde, we can head over to the automation hub and get a quick sense of build health on all our projects. And we'll see we're going to issue with change list 81. It looks like our perf test is failing. We're not getting our minimum FPS on this device. Now, this should probably be a warning, probably not an error. But for dramatic effect, I wanted you to see the big red bar. And when we open it up, we can see the same message. We can quickly read through our test data and see what's going on, all from the Horde dash. Now, crop out is actually pretty optimized, so I had to do some pretty horrific things for this screenshot. I wish I could say no villagers were hurt in the making of this presentation. Another thing I wanted to talk about, this is a tangent, I did warn you, but if we are thinking about deploying on devices, I think I want to just quickly promote Zen Server as a cooked output source. It's really cool when we're talking about working with different platforms like Android. I deeply believe this. If we can improve iteration, it will benefit the product. What this does is it allows us to speed up our iteration if we test on device in editor. It does this by not pushing cooked content to the device. Instead, it just streams it as it's needed. And so Zen Server is a new tool that maybe many of you know as like the new DCC system. And it kind of is that, but it's also can handle a lot of different things, and this is one of them. And turning this on is super simple. You just select Zen Server as cooked output from your project settings. Basically, it's going to deploy a little file. This little text file basically has a IP pointing back to your Zen Server. And if it all works, you'll get this message, and it can speed up. Your pipelines significantly. We were dropping huge amounts on our Fortnite tests. So I do suggest looking at this and getting it working. Look, but the thing is, there is so many new dev tools. How do you know what to focus on? I could wait till things get so bad that developers arrive to my door with pitchforks, and this would work, I believe, but surely there's a better way. And that better way is the Studio Telemetry plugin. It's a plugin that can be turned on in your project, and it will report a bunch of analytics back to Horde. It will show things like how long it takes to open the editor, how long it takes to get to Pi, DCC efficiency. Setting it up is pretty easy on the UE side. You just need to add these configurations to our default engine. Just make sure it's obviously your IP. We also need to tell the dashboard how to display this data and what metrics to aggregate into views. Now, this is definitely more complex. But once again, Horde ships with some pretty robust samples. You can add them into your telemetry store object in the global.ini. So this one's going to refer to metrics that we care about and how we're going to aggregate them together. We have another one that takes that, and it's kind of about how we're going to display that aggregated data, okay? And with that set up, you can see it, the analytics dash. This is kind of what we can look at. And just note, look, time to Pi, I think, is such a useful metric. Remember, in most cases, we don't care about like the number, but we do care about it changing significantly for some reason and being like, oh no. If it gets faster, we don't care either. It's good. I want to deploy on Linux, and I want to know I can deploy my test environment to the cloud much easier. Well, Epic prefers way of handling Horde deployment is by using Docker. I want to give you some general advice to get started with this, as well as how to build Horde and its components to make your own changes, because of course, Horde is source accessible. Horde source comes with a really useful build graph for handling a lot of tasks to do with Horde. It's called build-horde.xml. And you can see nodes like how to make your own MSI installer for Horde, or how we can build a bundled Docker image. This is the node we want. It will compile and package all Horde's tools, such as UGS, Horde agents, Horde dashboard, and they're all going to be ready for us inside the Docker build. So for those who don't have a heap of experience with build graph, this is kind of how we run it. We run UAT, we specify we want to run build graph, we give it the script we want to use, and we tell it what node in the build graph we want to run. And it's kind of as simple as that. It's so simple we could even make it a Horde job. Once we have our Docker build as an example, we also provide a Docker compose file. And this is going to handle the Mongo and Redis dependencies that Horde has for us. For testing, we're going to make a quick change to the compose file and tell it to use our new Horde server volume instead of the one Epic has provided. And to run it, we just run docker compose up, and there we have it. We have Horde running on the cloud. Sorry, on Docker. It's not on the cloud, it's on my computer. Another quick tip is that the compose file also mounts the data directory where the config files are. And this means we have easy access to them on the same machine. But this is probably not the way you want to access these config files, right? Can't we just use source control to manage these files? Yes, of course you can. And it's pretty easy to set up, and it provides some really cool levels of access and control. So instead of referencing our global file in our server.json using the relative path, all we do is replace it with a perforce address. Now, we're also going to need to provide some perforce credentials so we can actually access these files as well. To do this, if we do this, we're going to have some problems with our old references like this one. We need to consider our perforce workspace context now. The files are no longer in that folder, right? They're in the perforce directory. And so if we just host them all, which is kind of what we want, then this shouldn't be a problem. It's going to be ideal, right? So that's what we've done. And then we can just use the relative path. Remember when I said that all the paths specified here are relative to the file that we're writing in. So keep that in mind. But we also have some cool opportunities, in my opinion, to make things really much better. These are sort of subjective opinions that I have. But you see, we've got the stream JSON file. And if you remember, the stream file is where we define our jobs. It's where we it's where we want the people using Horde to write their tests. Typically, the build engineer or the technical director, they shouldn't, that's not for them. Like, it's about the people who want to use Horde to add their tests, right? And so what we want to do this is put the stream file in our project. And so what we can do is just move that reference from in our project JSON to another perforce directory, right? Into the stream where our project is. I like to put it in the build folder, but it's kind of up to you. And now folks working on the stream have access, depending, on their permissions, and they can make their own Horde jobs, which I think is really, really nice, actually. Now, we have looked at a lot of JSON files, and the truth is, if you're working with Horde, you're going to be swimming through these files. Because of this, I highly suggest that you work with JSON schemas provided by Horde server. It will make your life seriously easier. It should have been at the beginning of the presentation, but I didn't think it was cool enough, so it's down here. So for folks who don't know, these will essentially offer suggestions about JSON object structure. You can kind of think of it like IntelliSense, but it's actually kind of more simple. The principle is that we know what Horde is expecting, so we can make suggestions and tell you if you've kind of gone wrong, right? And all you need to do is open Visual Studios, go to Options, search for JSON, and then we want to add this URL, obviously your Horde URL, with that schema catalog. And to see it's working, you can just look up here in Visual Studios. It'll have the schema address, and this will help a lot. So I kind of think this is the first thing you should do, right? Up until now, anyone could just go to our Horde URL, and if they're on the network, and do what they wanted. And this is fine for testing, but in reality, we probably want some user groups to, define users and their entitlements, or even just have a history of who did what, right? So Horde has two major flavors for authentication. We've got OAuth 2, OIDC, and that's great if you're already working with those systems. But if you're not using one of those, Horde has a simple system built into it itself. And to enable it, you just need to access your server.json and change the auth method. And the comment says, change it to Horde. We do. We restart. Whenever you change the server JSON, you must restart. The other files are okay. First time we visit the page, it's going to ask for our admin password. Then we can set up our user settings buttons. We have this thing up here. We can add users by going to the account page. They're really simple to set up. But we have group permissions. And that means, even with this, some users could view and download artifacts. Some would have the ability to fire off jobs. That's already really cool. When a new user opens up, they're going to be able to log in, as you would expect. Just pointing out, they can see their entitlements. This is kind of useful for when you want to make your own access lists. Okay, really, really cool, but I wanted to end on one more subject, and that's the fact that Horde has a HTTP API that can do a lot of work for us if we want to integrate it into existing tools. Okay, this is really powerful. So you can find the Swagger definitions in the help API browser section of the Horde dash. And you can see that you can do a lot of things. I didn't want anyone to read this, okay? That wasn't the intention. I just wanted to show you a lot of things. From triggering a build to finding out build health. It's also really good for debugging as well, to pull out bits of information from the system. Here's an example of setting a notice inside of the Horde dashboard. It provides an endpoint and a structure of what we need to provide. And for those who have not played with Swagger definitions before, it even enables us to test it. So let's make a Horde notice to annoy everyone. That's a common theme that I like to do, if you picked up on. And if we fire it off, we get a message. This is a message for everyone. Horde is good fun, which I just think makes their day a bit brighter when they get to work in the morning. We can also use this API from external apps. That is, of course, what it is made for. Here is an example of getting this notice from within Unreal Engine, right? And this is kind of a silly example because you're probably going to use it from your existing tooling. But if you wanted it in Unreal, you can. And then that way, you can harass your team members when they're in the engine as well. So they really can't escape you at this point. And I think that's important. So what are some good next steps? I'd really recommend checking out the Slack integration. It can ping people when there are issues. This is really powerful for better setting up automated triage, okay? And it's definitely a great next step once you've got all this infrastructure set up. If you're using Slack, it's not too tricky. If you are using Discord, I know some developers use Discord. There was recently a talk done at Unreal Fest Bali about a group who release their code to do that. I think that's a great talk as well because it shows how to modify Horde, which is something that I didn't have time to get into, but I'd encourage you to look at its plugin system. Another exciting feature is for Horde is being a coordinator to distribute compute for remote code and shader compilation to speed up your dev iteration, right? So being able to distribute your compiling of the engine and use everyone at work's computers, and they're like, oh no, or not do that because you're respectful. But essentially distributing your work across multiple computers, speeding up your iteration. Very, very cool. Another thing, of course, is staying up to date and managing your expectations is going to be really important as well for any technology that you're really bringing into your pipelines. And so you can always check in with documentation to get a better idea of the status of any of these tools. I think this gives a fairly good idea of some of the things I've spoke about today, like the fact that we're still early days on analytics. We actually have Carl, who is a developer on the Horde team. Do you want to stand up? Yeah, rock and roll, yeah. But the reason I point that out is that this is a conversation that I've only just started. I'm going to be at the Dev Hub. Carl's going to be around. We want to have conversations. And my goal here was to get this conversation started, to get excited about this kind of stuff, what it can mean. Also be like, no, I'm not excited about it. I'm going to stick with what I have. That's fine. At least you now know. So thank you for coming on this journey. I think, how much time do I have for Q&A? 5 minutes. Okay, well, with all that, thank you very much. We'll dive to Q&A, and I might have to lean on my wonderful team here, but we'll see how we go. Thank you.